So I was like, okay, then 3 over 2.
Okay.
You got the first question.
At 0, we're at 0 at 30, 1/2. And then here we're at root 2 over 2. And then at 60, looking at our unit circle, right? The y coordinate at 60 is root 3 over 2. And then at 90, we're at 1. Boom. And then we're at root 3 over 2. And then root 2 over 2. And okay. I just lost my train of thought. There we go. The train of thought was derailed. There we go. Now, going around our unit circle, we have become in a spot where we are now below the x-axis. So our numbers will now be negative, and you've noticed that this pattern just continues to repeat. But now it goes in reverse. It's oscillating, isn't it? I just lost my man. I am not. Okay, 0. All right, there we go. Hey, let's go ahead and graph these. Right here. All right. You only have 2 abs every 2 times. Okay. Let's go through this. We're going to graph these points. We're at 0, 0 right there. And then we're at 30 degrees. So let's go like, 30 degrees is somewhere around there, right? And then we're going to do 60 degrees, like somewhere around there. So if we're at 30 degrees and 1/2, and let's call this right here, let's use that as 1/2. So our units will be quarters, right? So right here we're at 0, 1/2. And then we run into this problem that we need to know what exactly is the numeric value of root 2 over 2 and root 3 over 2, right? If I'm going to plot these on a graph, it'd be nice for me to know about where they are. So I'll put that into my handy-dandy calculator. Turns out that root 2 over 2 is approximately 0.71, and root 3 over 2 is approximately 0.87. And I'm rounding to the hundredths place because I'm just trying to graph these things. I don't need to be precise. All right. So at 45, I am at root 2 over 2, which is like, I don't know, a little less than 3/4. So like that. And then at 90 degrees, I'm at 0.87, which is more than 3/4, something like that. And then it turns out that this thing actually follows this same oscillating pattern down. And so far, it looks like we have almost what looks like a little parabola, right? But what happens for values greater than 180? Well, let's see. So we're going to be at -1/2 here. for 210. And then for 225, we'll be at what we said that was just under 3/4. So just under 3/4. And then over here at 240, we're at over 3/4. And then at 270, we're at -1. And then you'll see that this pattern continues to go on. And so there we go. We have the first 360-degree rotation of sine. Let's go ahead and look at what this thing does for further rotations around around the unit circle. I mean, isn't this interesting? We're actually oscillating as we go around the unit circle. We're coming up with this graph, right? So let's get on our hands down to calculator and let's graph sine. And in this case, we're going to use sine of x. I know I say theta a lot, but in this case, we're using our graph again. And we hit graph. And that's what it looks like. That's a fun little wave. And it just keeps doing that forever and ever and ever, right? Because when do you get to the end of a circle? Really never. Think about that. The circle has no end. No. Because there's still... So, this is called the sine wave. These are actually very, very important. You model things that oscillate using sine and cosine. So springs oscillate, machines oscillate a lot. Vibrations oscillate, sound oscillates, right? Right? Sound, the waves go like that, right, as they come to you.
Ocean waves.
Ocean waves oscillate. All right. They like go. Car engine oscillates. So many things oscillate, and that's why these things are so important. Okay. Well, there we go. We looked at this. We're not going to look at this other stuff. We did talk about what happens to this, right? And it's hard for me to show on a video, but what's going on is this wave is going like this, right? So yeah, as I'm going around the unit circle, did I get it right? It's hard to do. But you see what's happening? You see what's happening? We're going around our unit circle. Sorry, we're going around this unit circle, right? And as we go around it, it creates this wave. Kind of cool. I think it's a neat thing. We got two things going on. Yeah, it's hard to do. So we said we've already pretty much answered these questions. What happens to the end behavior? It goes on forever and ever. Is it odd, even, or neither? It's neither. And we described how it repeats. Let's look at cosine. Hey, what's cosine of 0 degrees? 1. Everybody that answered already has a gum gun. So. How about cosine of 30 degrees? 3/2. We're about to have an adventure. So it's a mystery. It's okay. How about cosine of 45? And then it just keeps going like that, right? And then at 90 we're at 0, right? And then now we've crossed into negative territory, right? We've crossed over the y-axis on our unit circle. And so now we're at negative 1/2 and negative root 2 over 2, and then negative root 3 over 2, and now we're at negative 1. The pattern continues. Negative root 3 over 2, negative root 2 over 2, and then negative 1/2. And now we have met the y-axis, so things are going to start to become positive after this. It's like when you hit your low point. Things can only go up from there. You thought. You scared cat. Okay. So same thing. But now we're going to start at 1. Alright? And then it's going to go to root 3 over 2, which we said was like, I don't know, there. And then you can see once you see the pattern, it's pretty easy to graph these things, right? Because they just follow the same pattern for our basic trig functions.
Like an old folder.
Now we're going to go back up to 1/2, and then up to root 2 over 2, and then root 3 over 2, and then 1. And so here we go. Here's the first 360 degrees of cosine. What? I don't know. He's always talking about yeah. Okay. I prefer to say the word ninja. Huh? Yeah. Okay, let's look at it. Let's look at cosine. And there it is. Yeah. Yeah, just zoom. Yeah, change your zoom. Hey guys! What could I put in my calculator to make a double helix? Like a little DNA strandy looking thing. You want me to put well, it's not the inverse, but you want me to make negative cosine? Okay, let's look at it. Let's see, does it work? Hey, it works. That's cool. Hey, what could I do? How would I make that same thing by shifting cosine? How much would I have to shift it over in order to make that happen? So if instead of just flipping it, right? So you guys reflected it, yeah? reflected it to get that. Well, how many units would I have to shift it in order to make that same picture? Our units are either in degrees or radians. He's trying a bunch of stuff, huh?
He pulled out the Bible with calculators. He pulled out.
Oh, for what are you trying to do? Is it not graphing? But you turn plot 1 and plot 2 on. No. You're gonna have to. Think on that for a second. Come on, think about it. Okay. No answers? What if I shifted this? $90. Oh, you did? Oh. Or pi units. So that what's that going to do? This is going to add pi to every one of my x coordinates, right? That's what's going to happen here. And if I hit graph, it works, right? Because 90 degrees is the same thing as pi. All right. So let's move on. Let's talk about if we were going to be graphing one of these, and it's not perfect like that, right? There's some transformations. Well, it looks like, and I could say f of theta is going to be 80. Let's look at first sine theta minus h plus k. So this is, there's another, we could also add, there's a gamma thing. If you look on your, if you wind up looking in your module, we're not going to deal with that though. This is as far as we'll go with transformations in this class. So this right here is your amplitude. This guy right here is going to be a horizontal translation. And this is going to give us a vertical. So that A, right? A is going to change the height of our wave, right? H is going to shift our wave either left or right. And K is going to shift our wave either up or down. Pretty simple stuff. Not too bad. Once you know it's theta, yes, theta. And theta could be any angle, right? 8 degrees or irradians.
No. There's usually a way to like check where.
All right, so I just wanted to give you a representation of this. Just a picture of it. Good for the video. But that's what it looks like, right? Your period is 2 pi. All right, so our period we're talking about is how long it takes for one complete oscillation. All right? Our period is, let's see, how long it takes for one complete oscillation. Our amplitude we're measuring from the midline of this thing to the top of the wave, all right? From a midline to the top of the wave.